reminder, if you have any announcements that you want to share with the MIS community, please add to the announcements Google Doc at bit.ly/miscannounce18. And I know a lot of these announcements that are currently on the doc are related to papers that people have recently published at conferences, but it could be any announcement that you think is relevant. So moving briefly to announcements. I see there aren't additional announcements other than the talk for next week. It's going to be learning programming at scale, code, data, and environment. Usually for people who haven't been to MIS before, usually what we do is we will read a summary of a paper that someone in the MIS community has recently published. And there's this big conference called CHI that's coming up in May, and so people have started to post accepted papers to that conference. So this first one is actually relevant to James' work. So this one is from Michael Niebling. It's called 360 Proto, and it's about rapidly creating augmented reality, virtual reality prototypes from paper. They conducted a series of design jams and developed 360 Proto. So if you're interested in learning more about that, reach out to Michael. We also have, I should italicize this right now. It has already been read. Okay. Then we also have a paper by Gabby Marcoux, Breakdowns in Homeschool Collaboration for Behavioral Intervention. This paper is about identifying problem behavior and providing appropriate intervention. And they discuss opportunities for promoting collaboration towards positive behavioral outcomes for children. So diversity of the types of papers that faculty here do, at least in the School of Information, and then that are going to be presented at CHI. So reach out to Gabby if you have any questions or want to learn more about that. But what we'll do now is we'll actually get started with our speaker for today. So today's speaker is Jane Prophet. She is in stamps, just arrived in July of 2018, right? So she's new to University of Michigan, but definitely not new to research in general. She's been a faculty member at places around the world. So if you have questions about that, I encourage you to ask her. She's also in stamps the Associate Dean for Research, and today she's going to be talking about some of her research on augmented reality and science more broadly. So I would like to bring up Jane Prophet. Thank you.
Thank you very much for that introduction. It's really great to be here. I'm just going to get control of my mouse. Yeah, it's okay. I'm just going to... I just want to start by giving you a quick overview of my other work so that you have a better context for me. So I've been working in collaboration with scientists since the mid-90s, and if I just scroll back, so some of my earlier pieces in '98 was an interactive narrative on CD-ROM that had a lot of embedded video, but also looked to the internet. So there was an HTML link, which at that time was kind of unusual. And prior to that, I'd been working with the team of us worked on artificial life programming. We designed a website called Technosphere that allowed you to design artificial creatures. Those creatures got put into an artificial life environment. So you interface with this via the internet and design creatures. They interacted and they sent you email messages about their everyday lives. So this was just before Tamagotchi. We had about 100,000 users. They created over 1 million creatures. So for that time, that was sort of unusual. And that really got me interested in more interested in simulation and artificial life. I went on to do a series of projects with Gordon Selly, who was the lead coder for Technosphere, which modelled arboreal forms, tree forms. So rather than modelling them by hand, sculpting them, writing algorithms that defined the way that particular species grew. And then they were then embedded via animation or back into large format photographic images. That's a good name, but that's another story. So I've had this ongoing interest looking at different technologies and how they affect our understanding of the world. The 3D printed heart that I made in 2004 from MRI data, and then silver plated. So it's a sculpture, but at the same time it's an object for thinking, as conceptual artists might say. How does taking this back into the operating theatre maybe change the way that surgical teams think about structures of the heart? And there's plenty I could say about that. How do we think about scale? We're all probably familiar with the ideas of self-similarity and in fractal mathematics and fractal images. So some kind of whimsical little CCTV pieces where leaves have a live camera. That image is then displayed elsewhere and you see those and they look like tree forms, growing crystals in tanks, taking a heritage apple tree that's died, flocking it in black velvet, putting it back into a snow globe, a giant snow globe that's 20 feet high, and put it into an orchard. Large-scale kinetic sculptures, again you've got the tree form. This one's made with the biomimetic engineer Julian Vincent, the person that came up with the term biomimetics, actually a biologist that became head of mechanical engineering when biomimetics really took off, so an interesting journey. So again, so the theme here, structure, looking at structure and thinking about different ways of translating structures into different material forms. And then a bunch of very different works. And picking back up more recently, going back to 3D printing, looking at CT scans, MRI scans, and fMRI, functional brain imaging, so designing experiments, co-designing those with neuroscientists, and then being in the scanner, being the subject, and creating work with the scientists in that way that then becomes a three-dimensional form for projection mapping. And this is just a few little stills you can see from a much more fluid projection map sequence. And then up to the more recent work, Pocket Penjing, which is what I'm going to talk to you about today. So that just gives, I hope, a bit of an overview of where I'm coming from. Oops. That's not what I wanted to do. Oh, sorry, I'm having PC.
At the top?
At the top. I know, you showed me earlier, and I thought I missed it. So sorry, thank you. Oh, thank you. So most of my works are in collaboration. Some of them I term bottom up, so we're all in it from the beginning, and others are more partnerships where people might be functioning in a more kind of subcontracting type model. This is definitely a bottom-up collaboration between myself and Mark Hurry. Mark Hurry is a flight sim expert, so he's designed flight simulation systems for the Thai military, for a notorious, infamous game in the 90s called Back to Baghdad. And he worked with us on Technosphere. So what our approach to graphics optimization is to look beyond what's happening in regular app design, look out into very high level, high capacity simulation, and to hack together workarounds and ideas from those different sorts of industries. More recently, because I used to work at City University in Hong Kong for 4 years, I met a colleague there, Yong-Min Kao, who is really from computer-supported collaborative working background, and he joined our team, and when I left Hong Kong, he became the PI for the second part of the project, that I'm going to be presenting today, bringing his expertise in user studies, which we really needed. So, augmented reality 3D trees, developed through participatory design. I'm going to talk through that design process, and developed for a reason, to try and support a situated sense-making of scientific data. So, what made us want to work with this problem? I've been in Hong Kong. I was living, as everybody else in Hong Kong is now, continues, living with a wicked problem, the wicked problem of pollution and climate change, but particularly pollution. And pollution, one might think, is quite easy to understand. You have a scene like this where the Hong Kong sky sort of landscape that tourists like to take their pictures against is so obscured by pollution that in front of it is a hoarding, and that's where you take your selfie. So you look like you've got the classic Hong Kong, but the real Hong Kong's right behind there. And Hong Kong weather changes. So sometimes it does look exactly like the hoarding. This isn't a constant, it's a state of flux. And sometimes it looks like the image that you're seeing above the hoarding, not because of pollution, but because of monsoon, a lot of moisture in the air. So we've got breathtaking views, and they're taking away our breath sometimes for all the wrong reasons, because we can barely breathe. At the same time, we've got, when we look out at the landscapes, some very difficult to understand messages. So are we looking at high moisture content, which is almost year-round in Hong Kong, in the 90 percentile and above in terms of humidity, or are we seeing pollution, particulates in the air? It's not always difficult, it's not always easy to know which is which. And there has been a lot of research that says that our perception of pollution has to be tangible for us to believe that we're living in a polluted environment. If we can't see it, or smell it, or maybe hear it, depending on what's emitting the pollution or the pollutant, we don't believe it's there. So tangibility is very important. Without that tangible sensing, if we can't sense it ourselves physically, we turn to apps, especially to try and work out the cleanest commute to work. And this is the kind of thing you see when you use air quality data apps in the Hong Kong region. They're really relying on numerical data that is not always easy to comprehend. And we looked at research by Jay Volter and Maria Engberg, who I'm sure many of you have read about, who've done a lot of research into narrative structure and sense-making and understanding, and particularly at their work on aesthetics, polyaesthetics and augmented reality. The notion that proprioception and engaging proprioceptive senses impacts in a beneficial way how much data we can take in and how we make meaning and understandings. So the difference between just looking at data like this on your app and looking through your augmented reality and just moving your body, engaging those proprioception abilities can increase our understanding and our engagement. So we also looked at older ideas about communication, like the circuits of culture models, and we looked at ideas from discursive design practices. And we very much wanted to make an app that was regionally relevant. So we weren't making an app for everybody, we were making an app for Hong Kong and maybe southern China in the first instance. And so we wanted to look at what those contexts of interaction in that region were. How are people with their devices? How do they move around? We looked at a lot of issues, so the POPs, the privately owned public spaces, how people are in public space and private space is very different from an American culture, for example, and how media texts are embedded in everyday life is, I would say, very different. So this became our research question: how could we engage with particular local users and increase understanding around this complex phenomena of pollution? And so we worked with local designers to develop a prototype that we would then use as a basis for further user testing and participatory design. So images of Hong Kong, but also we were thinking about what has a lot of salience in terms of cultural artefacts. What do people really understand and engage with? What are the kind of icons from local culture that people return to, both through museum experiences but also in popular culture? And we chose the cherry tree. Now, it doesn't grow, the cherry tree doesn't grow in Hong Kong because cherry trees need the climate to be cold enough at a certain point of the year to trigger off blossom development, etc. But the cherry tree is very iconic. A lot of people travel to experience cherry blossom season in places like Japan and Korea. And there's a lot of references to cherry blossom in Hong Kong culture. So we were interested in looking at the cherry blossom tree, something close to people's heart and very much embedded in cultural history. So taking some of those previous projects, now maybe it makes a bit more sense that I introduced you to my obsession with trees and the mathematical modelling of trees. We decided to develop a pocket Penjing. So I can see you have a lot of Asian colleagues in the audience, welcome. So you'll know all about this, I'm guessing. But so for those of you that don't know, that the Penjing is what is sometimes called the Chinese bonsai, but it predated bonsai. So Penjing were grown and nurtured and designed in China, an important part of Chinese culture. And what interests me about Penjing is also that often when you see one of these miniature growing living trees, they'll have a ceramic bench or a ceramic figure. Not always, but much more common in the Penjing than the bonsai that were later developed in Japanese culture. So the Penjing seem to express this idea not just of the heroic, beautiful tree, but of a human connection to the tree in their very composition, let's say. So we decided to try and make a Penjing that you can keep in your pocket on your phone. And that was also related to the incredible love of all growing and living plant forms in Hong Kong. Like seriously, nearly every single tree that you see anywhere has a label with a Latin name and a number over the entire city, even in the industrial areas. Almost every tree is tagged and very well taken care of. And people grow plants in anything they can get their hands on. So any little gas station or a backstreet workshop, which may not look that clean, they will have trees growing in an old oil can, an upside down traffic cone, and those trees would be, and small plants would be very well taken care of. So this is a sort of design. This is a design, if you like, an overview of how the features that we put into the app. So we decided to make a prototype that allowed you to choose from. At this point, there are two different tree types: a cherry or a eucalypt, and then to select a air quality data station or and weather station using what we call a global pick, a 3D pick. So I'll show you this in action later. So you swipe, you spin the globe, wherever there's a little map pin, you can select one of those, and that will be the location, the data that your tree's growth will be anchored to. We're using easy-to-print markers, so you can print out your marker, and anywhere you put the marker, you see the tree through your mobile device. And you can speed up time to see the tree growing, or if you're incredibly patient, you can just log on every day or so and see it growing very slowly over a matter of years. And we began with the idea that you could do some interventions. You could water the tree and you could prune the tree, and that if you did prune the tree, keeping with Penjing, you couldn't undo. So if you cut off a branch, it's gone. So technically, I think what's important here is that none of this is bleeding edge technology. It's all fairly robust. We've maybe combined some things that hadn't been combined before. There's a lot of examples of 3D pics. A lot of apps are scraping live data. We brought those together, and then we did something that we haven't seen until very recently, which is we've got real-time 3D L systems, plant structures that grow, and are growing depending on the data that they're reading in from that air quality station. And so the first version of the app had this interface, where you had a kind of band at the bottom where you could speed up growth, you could reduce pollution. It was all about tapping. And these were the kinds of images that you were seeing as a user. Wherever you'd got that graphic marker, you'd see the tree, you'd see it grow from a seedling and up, depending on the data, whether the data were conducive to growth. So this is it being shown, some screen grabs of the app in use in Australia. What we wanted to do, though, was only develop that prototype so that it was usable enough for us to conduct some participatory design. So we went through some paper development to get to that first version that I've given you an overview of. And then we ran these two much larger scale studies. So the prompts were very simple, which was that all ideas are good ideas. The students were going to work in teams, and they could feedback in any way they wanted. They could write, doodle, sketch, they could just verbally report. And the idea was they'd share their ideas as a team and then with all of the other teams. But there was no other prompt, there was no other direction given. I'm not expecting you to try and read that, but what we did was, with those 60 plus participants, we got them to feedback they were in broadly two different classes. So we got them to feedback, and we had two researchers that were using Coglit, so they were mind mapping the responses. So as those participants presented, they started to write in and get senses of topics and themes and ideas and criticisms, suggestions, and how they might group together. And so one of the things that we found was that over 6 out of the 12 groups, so that's 28 out of 63 participants, suggested more regionally specific weather events and environmental conditions. So they wanted to see more modelling of smog, typhoons and very heavy rain. And this came out often with illustrations. And so the way that people were presenting was in a format that is common to the way that Hong Kong students learn and present. So in keeping with every university in Hong Kong teaches in English and students present in English and are very adept at presenting in groups. Usually each individual in the group takes a turn and has a part of the presentation that they've worked out that they'll present. So those are just a couple of grabs from there. So not only locally recognised weather and pollution, but also more locally recognised features came up. So in Hong Kong, there's a very, very, very low crime rate. And the private space is at a premium. It's very difficult in most people's everyday life to get much privacy or to have outdoor space of your own, that your family owns. So mostly we hang out in shopping malls and parks. And so it wasn't surprising maybe there to see that this idea that geofencing could be a useful addition, that people would want to meet and compare trees in those sorts of public spaces, and that would be very comfortable. And these are all images from the participants that they brought to their presentations and gave permission for us to use. So obviously a sketch, and then, you know, again, bringing in these different weather effects, and then things that are much more about tying the app and the iconography in the app to culturally specific tropes and understanding. So in this case, this term made famous in a poem about conjoined trees being a symbol of love. And this, I think, was especially relevant because people immediately started to suggest how could the design be improved to enable sharing and to become a catalyst for people meeting and coming together. So rather than a focus on just the single user, many participants reported how could the app be used to bring people together. The other thing that came out that probably won't surprise anybody here is we made a simulation, not a game, but over half of our users sort of recommended that the app become more gamified, and you know, we're suggesting images like this. Then you've got the scoreboard, and there's a correlation sometimes between having a more social media connection in the app and the gamification at the same time. So sending the Penjing to other players, or maybe deciding to prune and cut a precious, beautiful branch and send in the branch. Also thinking, getting prompts that the tree was suffering or dying and you needed to do something. And then the final, on the far right, this illustration came through with this idea that if we could all meet with our different markers in the park, could we see a forest grow? So what we did was we took those ideas and we did a Wizard of Oz user study. Does anybody know Wizard of Oz? Okay, so I'll just run through it. So with Wizard of Oz, and this is Mei Chen, one of our research assistants that you see on the far left, and then one of the user groups. So she worked with a series of focus groups. And I'm just going to play a little bit of, just play a little bit of that, which I've got, I think I've got ready to go somewhere. So I'm going to talk over this is just what she would do. So in Wizard of Oz, we make a video that apparently, we make a video and I'm standing here, I'm going to play the part of Mei Chen, and I'm just telling you that my phone is now connected, I've beamed it through, so you're seeing live what I'm seeing on my phone. And you can hear the click as I'm selecting something. So I'm opening the app now. Here we go, it's opening up. Now, of course, this is what I'm seeing. So now the app's loading, and you can see here that the app uses what's called a 3D pic. So it shows a rendering of the globe, and I can spin that. I'm just going to spin that here. Here we go. Okay, now I can select one of those pins, and that pin will scrape live data from an air quality weather station. So I'll just select one of those now. So now the app is loading the augmented reality, and you can see I've got the graphic marker here on my lectern, and so you can see my lectern here in the image behind. So you can see that this is a fully grown tree, and I can see how many days I've got until I can harvest this seed. I don't have any flowers yet. And there's a toolbox down here at the bottom. I can go and check out more about the live weather data at any point just by tapping on the icons on the lower bar. So I'm not going to go, I took a pic of this earlier, but let's just go through. So the hamburger menu allows me to access other information about the app, and I can do that whilst looking at the tree. So you can see that what's happening here is that there's nothing like this on my phone. So we record the video so it matches the room in which we do the focus group. And so the Wizard of Oz analogy is, you know, that we're sort of behind the scenes and we faked it. So what we did was fake a number of the suggestions made by the first set of users, and then gather more data about what it was like to have a rough implementation of those ideas. So one idea was that the watering can, tapping on the water to water the plant was not intuitive and it wasn't very satisfying. If we gamified it a little bit, it would be much more interesting. So that's, again, obviously just a quick animation overlay. And then we've got here some mock-ups of gamification elements. The sense that you might have a diary or a journal, so you could look back over time, see what behaviours were most effective and increase your scores, or share that with your friends. And there you go. The other thing was, could you share images with your friends? Okay, so let me just come out of that. So what the Wizard of Oz did for us, so this is Lei Chen in the middle of her Wizard of Oz presentation, was allow us to run a series of focus groups with very simple prompts. So how do you feel about the visual materials? How do you feel about the game flow? What do you feel about the social functions that we showed you? Not all of which I've shown you now in the because of time. And what do you think the purpose of the developer is? What do you think this is about? What are we doing? And so taking the responses from those series of focus groups, we then implemented the ideas that seem to be the most important and have the most salience for understanding the air quality and having a motivation to continue to use the app. So this is just some evidence of how we implemented those. So one of the things was, although people were based in Hong Kong, what they wanted to do, they could make up to 3 trees, and they wanted to plant the same tree at the same time, scraping data from 3 different locations. And we had a certain number of locations, but they wanted more. So one of the things was to add more locations, so people could see the comparison pollution in different cities or they weren't all cities, but different locations around the world. They wanted to be able to take screenshots, store them in albums and post them. And so we have got this running because of social media, Facebook changes, we have to revisit that soon when we get outside of user testing into the app being out in the world. But we've got that functionality so that you can take a screen capture, you can give it a caption, you can post it straight to Facebook. And it's harder to do this with Instagram, as I'm sure many of you know. That's why we're with the kind of old fogey Facebook area at the moment. And then I'm going to just quickly play through this video that gives more of a sense of what is that?
Pocket
Penjing is an Android app at the moment, and it will be for Mac and Android. So first of all, we'll find the app on the phone.
I just want to give a sense of how it loads pretty quickly, because the problem with just showing stills is it's easy to think it's all faked.
Is it for both platforms?
At the moment it's Android, which is the most popular platform. It's Hong Kong and China, but we're
through that.
and then we'll port it soon.
And here you can see two trees have already been made. And to make a third tree, you just tap on an empty leaf area.
I'm also directing somebody that doesn't use it usually.
Different tree species. So first of all, we'll select the cherry blossom option, and then type in the name for our tree.
This is something we learned from Technosphere, that everybody wants to name the thing that they create. So having a number isn't enough.
Top right.
Probably more creatively
Now we
than
can
that.
choose which air quality data or weather station we want to choose by spinning this 3D globe with a 3D pick. And on the globe there are a number of different sort of push pins, map pins. If we select one of those, that will choose that particular weather station. And so there's one in Wuhan, so we'll select the Wuhan one.
The reason for choosing Wuhan is because it has the most beautiful cherry trees and has a very popular blossom season.
Now an introductory animation here will just briefly run through a graphic representation of the interface and how different
Which is now outdated,
features
so
can be activated on the phone whilst the app's running. Again, this can be interrupted at any time. And what's happening now is that the augmented reality.
So obviously we've changed the interface so you see that it's loading, but it loads pretty quickly. That's a
You can see the
typical kind
graphic
of loading
marker
time.
that's down. So we've now got the tree starting to grow. There's a little green area in the middle of the screen. So we can, first of all, let's sort the temperature out, which is alerting us that it's too hot. And then if we can speed up tree growth, so we can see this happening faster, you can see the cherry blossom on the right, that little icon increasing in speed. And that should get our tree to start to grow more quickly.
So it goes up to 4 times in terms of speed. One of the issues
So
that
up comes the seedling.
one of the things we've got an issue with is that
And
the
that's growing in
GPU
real time
just
3D.
can't
So if
support
we move the phone around,
more than
we can
4
start to see
branching
that from different
levels.
angles.
So the level of complexity of the three-dimensional form is limited by this generation of phone. So this is a couple of years old, so
And
when we do the next stage of development, hopefully we can improve on that.
you can even put the graphic marker, which is down here, you can hold that any way you like. For example, in your hand. So if I put that in my hand, you can see me sort of holding the tree in my hand, and it's growing.
You've got a certain amount of lag whilst it's actually growing speeded up, and then when you stop the growing, the slight lag that you see here, which is on a very old
There's also
Samsung, by
a
the way.
feature for pruning the tree. There's little scissors on the screen. So if we tap those and tap anywhere on the tree, and the branch will be cut immediately. Oops, there it is. I can rotate the tree actually just by turning the marker in my hand here. So you can see we've pruned that tree. It looks a bit sad now. And anytime we want to, we can come back in and reload a tree that we've already made. Our proposal.
So I'm going to stop that there and just finish up so you've got time to look. So we've actually done more. Sorry, I have a mouse rebellion. There we go. We've actually done more development subsequently
and implemented things like the watering can with particle systems water, various other ability to have a microscope and get more data, and to build out those both the photo albums and the journals. And then we're just finishing this competition in Hong Kong, which was to just see if people would use this and to be able to do a more longitudinal study, so to gauge people's understanding of pollution before and after use. So that's just wrapping up at the moment and was focused on City U university students. So thank you very much, and I'm open to any questions or comments that people might have.
We have about 15 minutes, 10-15 minutes for questions.
Sure, back.
Thank you so much for the presentation. I really like the idea of the comparative element of 3 trees in different locations, and I didn't quite get it from the pictures you showed. So I was curious, to what degree can you actually see the differences in these trees and how they live in their climate? And have you had, even though your survey isn't done, have you had any observations of the users of how they found how they perceive those differences, and if that kind of impacted their understanding of pollution?
Thank you. So we've had feedback through the process that it would be good if the expression of states of health were more pronounced. So the blossoms and the trunk of the tree change colour, but one of the things that we'd like to do in the next implementation, which we want to go and test in schools. So at the moment we're at that point where we need to talk more with high school teachers, we'd like to do a US study and implement some things in the app and some contextualising, maybe worksheets or toolkits that teachers can use with the app to deliver kind of climate change, pollution related parts of the curriculum. And I think for that actually the trees need to express more dramatically than they would in real life. So at the moment they may be a little bit too realistic, that the blossoms go brown, but maybe we've been talking about in response to user comments actually making those the physical, the tangibility, if you like, of the pollution or the overwatering, over rain or not enough rain more visible. So that's a really good point. Yeah, we'd like to do that, make it more extreme. Although it's interesting that nobody came up from the user groups with ideas of really extreme behaviour of the trees. But as an artist and with the other work I've done with trees, when we first started to develop our systems trees to model the growth of English oaks in the early 2000s, we made a mistake in the algorithm and we got a very strange looking tree. And Gordon Sully, who was programming it, was really upset. And a lot of Anglo-Saxon expletives and a whole day of programming wasted. And I said, well, this is really fascinating, because to me, what he'd done was the three-dimensional tree looked like a tree that had been heavily pruned and then left. So you've got some growth, it was truncated, and then all the branches just went up. So I'm actually all for thinking about making it much more extreme and more expressive and less realistic. Yeah.
That's such a wonderful tool that you have there, and I wonder, you started by saying what the wiki problem is, and it's that there's pollution. Is there any way that this can also help to deal with behavior so that people realize what is their personal input in what's happening with the tree? So
yeah, I think this has come up quite often, and I think there's lots of ways to go with how to connect an app like this, or how to develop the app so that it might affect behavioural change. And that's something that we'd like to talk about with teachers. And many of the pieces that I've done with scientists, whether they're from stem cell research or neuroscientists, and now this work are really, I would say broadly, they're about the public engagement with science and how to, so the starting point is usually how to engage people in the discussion. And then there's a lot of people that find that very frustrating and say, well, we need action. And I agree with that. But so it could be that we can develop this in such a way as to prompt different behaviour, or it could be that there are spin-offs from this that prompt different behaviour. So I've been looking at, for example, can we tag a virtual Penjing with a real tree and exchange data that way, which wouldn't be this app, it would be a different animal, a different kind of AR or VR experience. We've also done some tests and experiments with geolocative AR and making a walk. So could you plant a virtual tree in a highly polluted area, and if you planted enough, would it mitigate pollution? And could we then connect that to the planting of real trees? Or if you chose to walk, can it reduce your pollution footprint? So there's lots of ideas we've been considering. What we wanted to do was to bring back the prototype, do the participatory design and see where that led. And one of the findings actually from the pre and post use that, you know, is somewhat depressing is that there was a definite increase in awareness about pollution and climate change from using the app, but there was no change at all in how much those 18 to 26-year-olds were willing to spend on pollution mitigation in a year. Not even a $10 a year change in what they were prepared to do. So I think it's a very important question, and that's why I want to go out more to education experts about how is best to bring those things into or around the app.
So just going with the cherry blossom metaphor, like the blooming period for cherry blossom is quite short, right? That's like 1 to 2 months. So how does like extended use of this app with a cherry blossom tree work?
Yeah, that's a good question. So the tree, the cherry blossom tree, it's not. This will bloom any time of the year.
Okay.
in the AR app.
Okay.
So it is clearly not.
Okay.
Behaving the way a real cherry blossom tree would grow. But what we've done with the programming, the behind the scenes code is such that we could have, say if we ran it off a PC, we could make a much more complex 3D, we could grow much more complex 3D forms. We have actually got the L Systems rules that are based on Cherry Growers Association research. And we could in effect have something that you would see every day in your lobby that would be behaving as it would that moment of the year. So right now it would look kind of twiggy and there wouldn't be much going on, maybe a few little buds would be appearing. So the way that Mark Hurry and I try to work is we have sessions over a period of weeks where he's constantly going, Moscow, Jane, Moscow, must have, could have, should have. And I'm coming up with loads of ideas and he's usually saying, no, we can't do that, can't do that. And then usually what happens is within a week he comes back with a plan of how to do them all, because he's very good at that. And then what we do is we decide which ones are really probably the most important for the initial idea, and we bring people in to have discussions in small groups about that and sketch them up. But the could-haves and the should-haves, which are like, could we do a really big one? Wherever we can, we build that into the back end, so that rather than recoding it from scratch, we can pull something out and do something different with it. We can't do it with everything, but that's what we try to do.
Okay.
So.
Thank you.
So you mentioned engaging teachers to get feedback and also how there were no attitudes have changed for this 18 to 26-year-old group. Are you planning to expand the audience for this to something that's broader than maybe that 18 to 26-year-old group? And would the app have to change in any ways for these audiences?
Yeah, so we work with that group, and we did work initially with students that were on a game design course, so they were obviously going to have a certain kind of bias. So that's one of the reasons we've run the much larger competition, which is participants from right across the university, but they are all predominantly undergrads, so they're that kind of age, 17 to maybe 24 mainly. We're really interested in testing in schools, but also if we're going to test, because the Hong Kong team is finished and they have other projects they want to get on with, so everything's come back to me I can now run with it here. So obviously there may well be design changes we need to make for a US user as well. But I think looking at the high school user is interesting. I think also, each education system results in undergraduates or high school students that have different types of priorities and awarenesses. And so I'm certainly not suggesting that if we did the same testing here, we'd get the same results. I suspect they'd be different. I don't know quite how, but I'm sure they would be different. So I think now we've got it to this point, now's the time when I can go and have conversations with people at high school level education and talk about what would need to be added or changed in order to do another round of testing. But it's also at that point that I'm sure you've all been at, which is, do we carry on or do we just let it go and move on to another project? I kind of don't want to let it go yet, because it does, people do have an affection for it, which I think could be, it could be something we could expand on. But I'm sort of on the edge of, do we do another round of development or not? At the moment, I'm thinking we should, because of the feedback we've got over the last few months.
Okay, so let's thank
Thank
Penjing.
you.
And you're welcome to come up and ask any questions or grab more pizza.